get the fuel economy and the performance. You can see on the leading edge we don't even have an air dam. You can see the scalloping that starts right from the front. We added these panels also for aero as well as for noise, and worked their way all the way back, paying attention to the details that even around the suspension components, if you sighted down the front of the vehicle, these would stick out, so we wanted to make sure we had some good laminar flow. And you look at how this transitioned to the back of the vehicle, how we have this exiting to get the correct airflow, some of the diffusers here, so we paid attention to how we were going to do the aero. Now let me start on the rear suspension. You know, when you think of fun to drive, you kind of think of ride handling, think of the steering and the brakes. So let me kind of touch on all three of these. This is Cadillac's first 5-link rear suspension. And the first thing I'd like to point out is when you look at the links, and all 5 of the links, they're straight. There are no bends, there are no twists. These are straight links, and you say, why is that important? It's because if you start bending links and having things change in the link itself, that means you're putting a moment into the suspension. And if you put a moment into the suspension, you have to accommodate it by either beefing it up, adding a larger bushing, or doing something of that nature. You can also see we put the lightweight holes in here, so we have them straight and we lightweighted it. And then when you couple the suspension into the body, and you'll see it here as well as on the other buck, the body lines up in line with the suspension. So in other words, you look at the rear cradle here. Here's the 2 cradle mounts, and you look at the rear cross member here on the body, and it's in direct alignment with it. So from a lateral load standpoint, there isn't any change in the loading. And then you look at the parts, and they got the light weighting. We have the holes in it. Another element I want to point out while I'm here is the rear drive module. We offer on our FE3, we offer mechanical limited slip. We often get questioned why this is a cast iron unit. And as I mentioned, we had to have some fuel economy and performance. We're looking for 50-50 weight distribution. We did a lot of side studies on understanding the fuel economy. And if you compare an aluminum differential case housing to a cast iron, the cast iron offers a couple of benefits. One is the thermal expansion properties of cast iron are less than on aluminum, so you don't have to press the bearings in so tight, you don't have the friction losses. 2, obviously from a noise standpoint, there's a lot better noise coming out of cast iron. 3, you can size it smaller from the efficient packaging sizing. You look at what we've done with the axle shafts, we bolt them in. We don't have the spline, so there's no lash in the system, so they're a direct continuity, so there's no driveline feel when you're driving the car from a smoothness standpoint. Let me work my way to the front. You can see how we've used aluminum components. You see a lot of the lightweighting. If this were an all-wheel drive unit, we have the all-wheel drive unit here, which is a Borg-Warner system that is a gear drive system and not a chain drive system. And again, we did that because of the compact packaging, so that when you sit in the passenger side, you don't have any footwell intrusion. Let me talk a bit on the front suspension. You can see immediately how small and lightweight we made this. The componentry is small, but also it's made out of aluminum, again with the lightweight holes. If you look at the handling as it goes across, it's in line with the lateral. This vehicle, to have a vehicle to be fun to drive, this thing has to be settled and planted from a roll standpoint. And when you get the loading from a lateral, this car will stay planted. And importantly, as you make your way around, this here is our double pivot on the bottom of the control, or on the bottom of the knuckle. And the reason we separate this is that when the loads of the road go into here, you don't feel it in the steering. And so now we have a rack EPS system. This is a ZF belt drive rack EPS system. So obviously you do the EPS from a fuel saving standpoint, but we did a rack system so you get the precision feel. Then we went to a belt system because it's even more precise and it helps from an NVH standpoint. The other thing I want to point out as you look at all of this front and rear suspension is we paid attention to the grams, not the kilograms, and every components had to earn their way into it. So for example, rear suspension, front suspension, typically you might use an M14 bolt. Instead we used a lot of M12 bolts. You say, well, what's the difference? If you take a typically sized M14 bolt to a smaller M12, 36 grams a bolt. You look at a nut, that's 12 grams. And it added up to be about 1,000 grams a kilogram in the rear and about 200 kilograms in the front. And that's the kind of attention to detail. And lastly, from a few more points on the suspension is we're very proud that we have the MR suspension. And we had the MR and the CTSV. We've got the next generation in this vehicle. You've probably experienced MR, but in the essence of what does that do is that magnetic ride at 60 miles an hour, it can read the ground every inch. And it can respond in 5 inches to go from full hard to full soft. So it can read and articulate and change in that amount of time. And then lastly, I want to talk about the brakes. You obviously can't have a performance vehicle without having the right brakes. We offer a 4-piston fixed caliper Brembo, and we've measured 60 to 0 at 129 feet, but I'm sure once you guys get an opportunity, you'll get a chance to do your own measurements. So with that, I'd like to turn it over to Larry. Larry's going to talk a bit about the body. Take it away. Thank you.
Thanks, Ken. And I'll have you take a few seconds and readjust and reorient yourself around the body. As Ken outlined, we challenged our chassis engineers to make efficient use of materials in the chassis development, and we did the same with our body engineers. Again, to use effective use of the materials in order to provide a superior structure at a low mass. And I want to just highlight for you a few of the materials that the engineers used and employ while executing the superior body. I have to start out with the common steels. The exterior of the body is always going to demand common steels in order to achieve the formability that's demanded by our designers, those crisp lines to execute the themes that they've developed in the studio. We bring out through those panels on the outside of the car. But that's where it stops. The use of the common malleable steels. We walk into the body and we begin to employ the lighter weight materials. Bumper beam, the forward crush cans that are bolted in. This is all aluminum. As I walk back and I'll highlight the cast aluminum shock towers, the first application of the cast aluminum in a General Motors car. We use the casting and at the interfaces between the aluminum and the steel. It's riveted, also adhesively bonded to ensure that structural and stiffness that those components in the body have to have in order to provide that good handling of the vehicle. And where we amplify or accentuate the structure, it's straight links both in the cross-car transmission of loads and then also in the strength that we get between the tower and the hinge pillar. As I go back a little bit further, I want to highlight cross-car aluminum IP beam that's used, and you can see the varying sections as you go across the section to support the steering column so that you have a solid steering column. You can see in that area, and then as you go further across, the structure is only there where you need it. Again, what Ken had said, every gram had to earn its way in here. It had to perform in the car. Another highlight of area I want to share is the highlighted blue panels. These are the press-hardened materials. It's one of the hardest or the strongest structural the steel parts that are used. We use those in critical areas such as the A-pillar and B-pillar. That's in order to gain the strength, structure that you need, but also minimize those sections so that you maintain and ensure that you have good vision, low obscuration through the windshield and door. In addition to obscuration, you want to maximize your entry and egress opening, so you minimize these sections, both in the A-pillar and B-pillar, in order to do that. And we've employed the press-hardened steel. Along with, I like to highlight the B-pillar as an example of our engineers taking every gram is important. You see the scallops that you see throughout the panels, even down the pillar itself. Those scallops were taking unnecessary material out of the vehicle. You've got holes punched in not critical areas, but areas that carry quite a lot of load. in those areas like in the package shelf where you see holes punched in. Anywhere where that material was not used to transmit and carry load, it was removed. I think what I like to do right now is I can't take a piece of the body off to really share with you just what effective use of material is, so I have to use my chassis buddies to demonstrate what we can do with materials. This happens to be the one of the engine mount brackets I've taken off the other side that supports the powertrain in the car. It's again the use of materials. I'll pass it around just so you get an idea of what it is. That's a magnesium bracket. It's a little less than a pound in order to support the engine. That controls all the torque and bounce and of a very massive, well, not call it massive, lightweight powertrain, but in comparison to what that bracket has to do, it's just an example of the use of the materials. So with that, I'll open it up for questions. I think